All right, friends, welcome. It is week 3, lecture 2, meaning it is the last lecture before we start the belt exam. So there's a lot to go over. I am recording now, but there's a lot to go over. So let's just jump in and dive in. Just as a reminder, you still have core assignments due tomorrow. So they are due Friday. These are Friday, April 8th, tomorrow. And they are average height, histograms, and box plots, and project 1, part 3. If I could ask whoever is talking to be on mute, please. Dana, thank you. Okay. So let's just jump in. Again, just really talking about the belt exam eligibility. Perfect. Belt exam eligibility. I sent out an email today. You all should have received it. And so it let you know if you were eligible or not. If you were not eligible, then that means that there is something, I let you know what was going on. And so if you were eligible, you should be good to go. Right? You would have gotten a, hey, you're eligible, no outstanding submissions. If you were not eligible, I specifically told you what I'm missing from you. If you have any questions, feel free to reach out to me immediately. And I we can kind of work through that. The way it's going to work is, especially if you're eligible, you're good, right? Like do your core assignments for this week, for week 3. But what's going to happen is tomorrow, probably more around 10 o'clock, because, people aren't stuff's not due until 9, even if, to become eligible. So I want to make sure I go and grade those. So give me about an hour, but around 10 o'clock, I'll be sending you an email. What that email is going to have is a ton of information. I'm also going to be giving you this, which is just our belt exam slides. This is just going to be policies and information as just to remind you if you're like, oh, what's going on? It's a lot of stuff we're going to go over today. Exactly how this works. What are the belt exam rules? I need to update the dates. So if you see all those weird dates, just know that you will be accessing it through a different thing. We're going to talk about all this today. And then at the end, I give you some tips and tricks, and then I give you some music to maybe code to. There's some of the stuff that when I'm doing something, I like to code to these playlists. So just give you some of those. So you'll receive that. You'll also receive an email that's going to have everything for you along with the code. So that code is going to be what you use to go and unlock your belt exam. Just as a reminder, you have 24 hours to complete your belt exam, given that there's 24 hours left by this submission time. So you don't have to start it tomorrow. You can start it Saturday. You can start it Sunday morning. Again, if you start it Sunday morning, it's still due, regardless of when you start it, it's due by 11:59 p.m. Now, if you started on Friday, you still only have 24 hours. So you don't have until 11:59 p.m. But you will have 24 hours completed. It will not take you 24 hours. I can promise you that. It varies about how long it takes people. So just know that I would set up a time that you are not going to be disturbed, right? Set up a time where that you can give ample time. Also, what I do suggest, if you can swing it, and one of our TAs, Adam, always suggested this, is he would actually start his exam at 5. He would go through, he'd clean, he'd make sure he did everything. And if he got stumped on anything, he would sleep on it. Knowing that he got far enough, he would sleep on it, come back to it the next morning because you have plenty of time within the 24 hours. And then he would go and assess and try to figure out, anything that was sort of stumping him. So it's a great, great plan. Obviously give yourself enough time, but don't just sit and stare at it. If there's an issue, you can get up, walk away. If you're really stumped on something, go move on something else. Okay. So once you unlock you can unlock the exam anytime after you receive the code provided in your email. So again, whether it's on Friday or Saturday, doesn't matter, or Sunday, doesn't matter. As long as you have that code, you're good to go. I recommend, now you have to do all of week 3's assignments, but if you're really sort of struggling, I'd recommend you do at least 2 out of 3 assignments before unlocking the exam. Just because, they're all due tomorrow, but again, there's this week material on the exam. That's like half of it is having to do some sort of visualizations. So make sure you're familiar with visualizations. It's not just on week 1 and week 2. Sometimes students get confused with like, oh, but only week 1 and week 2's due. fully, all that. So there is week 3 material on there. And again, it must be submitted by end of day Sunday, 4:10. You can use any materials on the exam. So if it's notes, if it's classwork, if it's Google, Stack Overflow, anything you want, but you must cite your sources. This came up yesterday in the mock belt exam sort of walkthrough. Citing your sources is absolutely important, but let me just walk through what that means. If I taught you how to do df.info, which unless you had any sort of data science knowledge, I'm probably the one, or the platform's the one who taught you how to do df.info. You don't have to quote that, right? Or you don't have to cite that. That's sort of a generic, like, okay, we would hope that from memory, you could do this on your own. It's more of, if I wouldn't have shown you how to do the for loop to iterate through all the different columns that are objects and get all the value counts, if you were just to pull that code out of somewhere, I would hope that you would cite something, right? If you go to Stack Overflow, you're not going to get a worse grade because you cite anything. You're not, like, it's not hurting you at all. In fact, I was just seeing a TikTok the other day that said things I wish I knew as a data scientist when I started. And one of them was how serious it is to cite your sources, because it can really ruin your career, right? And so make sure you're citing your sources. If you find anything on Stack Overflow, you can cite your sources. You can say something very similar to this, code adapted from, and just put the link there. And so if you didn't obviously do the, word for word code, but you got the idea, just put that. That doesn't hurt anything. But again, what would happen is if there was a piece of code that was really, really advanced, I might, ask to have a meeting and say, hey, will you explain this code to me? Help me know what every single piece is doing, right? And if you can't do that, then we will assume that that was sort of just picked up and taken. And we have a strict 0 policy for academic plagiarism. And yes, thank you, David. We have a strict 0 policy for plagiarism. So if you do get caught plagiarizing, you can get actually kicked out of the boot camp. So please make sure that when all else fails, cite. But again, if it's like df.info or how to do a group by, you don't have to cite that unless it's like an advanced group by, then yeah. And you learned it on Stack Overflow or somewhere else. Cool. You must complete the entire belt exam entirely on your own. So you can't get any help, right? You cannot work with anyone else, and there's any collaboration. If we find out that you collaborated or you have the exact same code as somebody else, and it's very obvious, that is cause for expulsion. So make sure you don't do that. And then don't post anything on GitHub, right? So when you submit this, you're actually going to download the IPYNB file and upload that. You're not going to put it on GitHub and then send me a link. We want the actual file itself. One thing to also note, as in this time, TAs can see if you've opened the exam or not. And so if you ask for TA help and you have an exam open, they cannot help you while you have an exam open. So when it's unlocked, TAs, exactly like David, TAs won't talk, right? Now, if you are saying, I want to make sure I know this and take it on Sunday, and you have a question on Saturday, you can still ask questions as long as your belt exam is not unlocked, right? As long as you have not unlocked the belt exam, then you are good to go. And you can ask TAs questions, just either DM them or in the group say, hey, this is a question on this, and then you are good to go. But you cannot get help once your exam is unlocked. Just as a reminder, tomorrow is the day at 9 a.m. for you to get any outstanding or missing assignments in. No codes are going to be sent on Saturday or Sunday. So even if you're like, oh, I'll just get it in by Saturday morning, I will not send you a code. You have missed the boat for the first round. So there will no codes sent Saturday or Sunday. Again, you can contact a TA through a direct message on Discord. If you have process questions like, hey, how do I do this? Not how do I do code, but how, how do I submit this? Somebody asked, how do we know? Whenever you submit a code, I can look in our back end and see how long you've taken and how long it's been submitted. So we have absolutely no secrets. I'll tell you, frankly, I can see the exact time and how long you've had it. So, it's like the eyes of Sauron. I think that's a Lord of the Rings thing. Cool. You can't contact any students. Don't post any questions on Discord. I know that I've said that a couple of times, but I just really want to reiterate, you cannot have other people. Now, one thing I do want to say is if something goes wrong on the platform when trying to submit, right? If for some reason the platform is not working or there is an issue, email me immediately with your backup. When I say immediately, it must be immediately. If you, because again, I can see when you started it, how long the 24 hours was. If you don't message me until 45 minutes after the 24 hours and say this wouldn't accept my belt exam, I'm not going to accept that, right? Because that was 45 minutes that you could have just extended and needed a little bit more time. So if you do not send me immediately when you're trying, once you have the issue, send me a screenshot and then submit the exam that way, and then we will take care of it. I would encourage you, take a screenshot just to make sure. And as soon as I grade it, then you'll be good to go. But yeah, if you have an issue, you need to reach out to me immediately, like within 5 minutes of the issue. Not anything like past that. I'm not going to accept that. Cool. Any questions so far?
Can I just say something quick, Will? I just want to encourage I just want to encourage all you guys, like, the reasons why all these things are here is because the point is so that as a data scientist, like, this is what I've learned, this is what I can apply. Like, honestly, asking somebody else for help or cheating or finding a way around it, it's pointless. It's not really actually gaining you anything, and it's really going to make you better. And even if maybe your exam doesn't go as well as you thought it would, that's all right. You're going to learn from it and you're going to grow because you're going to see, oh, okay, this is what I either did or I didn't know, or this is what I missed, or this is what I could have done better or different. So that's all it is. It's not like do's and don'ts. It's like, there's good reasons for all this stuff. So I'm just speaking from experience too, how much I learned, because it was like, I got to solve this problem on my own in 24 hours and I'm going to get it done. So I'm sure you guys will be awesome. So
yeah, thanks for that. Cool. The way it's going to work is also within the belt exam email. I will send this link right here. But it is actually to our old platform, this learn.codingdojo.exams. And what that's going to do is it's going to bring you up to this guy right here. When I send you the code, you're just going to copy and paste that code, right? And then say unlock and start exam. Again, once you click this unlock and start exam, the timer starts, right? Perfect. I'll look into that, Michael. Thanks for that. Michael said, I got a notification on the platform today that the system was going to be down for maintenance Sunday evening. Did I misread? If that is I will absolutely figure that out immediately. If that is the issue, if you do run into that, send it to me. Send it to me, and then I can, again, with a timestamp, I can send it over. So, okay. So what you'll do is you'll put your code here, unlock, and then it'll bring up your prompt, very similar to the mock belt exam. And so then you can get started, right? Have your data, work through that. Again, whenever you are submitting it, you do not, if you see this video portion, you don't have to post a video. So other programs do have a video. So you don't have this video. Don't worry about that part. All you're going to do is zip up your exam files and upload it here. Again, don't give me a Google Colab link. Don't give me a GitHub link. You have to actually zip up the files, do that. One thing that is optional, you don't have to, but I will send you, whenever I send you the belt exam code, I will also send you this starter notebook that you can feel free to copy and paste, or and then use. The reason I send this is you can put your name and your date, but then I also put in, this is your criteria for what you are going to be graded on, including the points. The belt exam is worth 10 points. You have to get an 8 or above to pass. It is a pass fail. So if you get an 8.5 versus 9.5, there's no difference, right? You pass. But you must get at least an 8 in order for you to pass the exam. Here on this starter, the idea is that you can go through, analyze, do whatever you need to your code, and make sure that you do every piece. If you go in and edit and just put an X here, then it does that, and it will sort of say like, oh yeah, I got this done, all good to go, right? Sorry, I had that space. It creates a little check mark for you. So you can go through and say, all right, did I handle missing values? Or did I make sure that all missing values are dropped or imputed? That's worth 2 points. If you don't do that, the best you can get is an 8, meaning the rest of your exam must be perfect, right? And these are not there's no partial points. So if you didn't do something, you lose the entire full points. So it's not like you'd lose like 0.15, anything like that. So it's either you did all this or not. So this is exactly the criteria I'm grading you on. Also, what I wanted to show you is in your feedback document, there's a little tab called Belt Exam 1. It's there too. That's where I'm going to end up posting your grade. But these are the exact things that I'm grading you on. And you have access to this, so it's nothing crazy. So these are the exact things I will grade you on, including with the points. So make sure that you are making sure you hit every single piece there. Again, I want to be no surprises. You don't have to use that starter notebook. You can do your own thing. All good. Just wanted to provide that for you as a free resource if you guys wanted. Okay, so please be aware that every data set and problem is different. The sample solutions for the mock belt exam that we had, it's supposed to say the, not this, for the mock belt exam is going to be different, right? The way we handle things, the certain things, handling the gender column, right? Like there's going to be issues in either one that you're going to have to make assumptions. You're going to have to dive into the code and deal with. If you just try to copy and paste that, I didn't give you guys the code for a reason, because I didn't want it to be, to where you could copy and paste. But if you just go through the video and do copy and paste, it's not going to work, right? So make sure that you are understanding the data that you are dealing with. Okay. Any questions? Okay. Just a little overview of the process. Here's a little bit of a suggestion as you're approaching the data is do some initial exploration, answer these questions, get a feel for your data set. What are the columns? And you guys know how to do this, .info or .dtypes, what's the type, how much data do you have? Are you missing data points? Then once you explore your initial exploration, you go and you start cleaning your data, you answer these questions. Then you do your univariate, so just singular column visualizations, and then your multivariate, so multi-column visualizations, which is what we're going to do today. Ashley asked, what about a zip file? So there's a certain size that you can submit. So if you have to, you just zip your file. If it doesn't, there's a certain size that you can submit to. So if it's too big, it's over 10 megabytes, then you have to zip it.
Is
Cool.
Is WinZip free? Because I don't know if
Yes, I believe so.
Okay.
I think I have WinZip on my Mac, but if you if you have a Mac, you just right click the folder and say, or the file and say compress. I don't think the file in itself should be, if it is for some reason, or if you're having issues, just send it to me and let me know.
Okay.
Hey, this was too big and I couldn't figure it out. So, or if there was like a paywall, just send it to me. You don't have to pay for it. So,
Okay, thanks.
yeah, cool. Okay. Any questions about the belt exam? That's all I have to talk about. Any questions? A massive water jug. It's super hot here in Seattle, like 70 degrees. Okay. All right. So today we're going to do a little bit, it's going to be like a half and half class to where we sort of talk more theory and then we go through and we're going to build out some multivariate models. Cool. So learning goals today is we are going to learn multivariate data visualizations. We're going to interpret correlation plots and identify correlation with scatter plots. And then we're going to create a 3-variable plot using Seaborn. Seaborn's got a really cool trick to just throw in a third variate, like a trivariate, in just one of the arguments. So it's pretty cool. Awesome. So when we're talking about multivariate analysis, we're meaning that we are exploring multiple variables at the same time. So we mostly just look, and just to know, when we do this, sometimes we mostly just look at 2 variables or 2 columns, which is also known as bivariate analysis. So like money over time would be, a great example of that. We might have different years, but it's money over time sort of thing. There is, again, trivariate, which we're going to look at today, but typically, and all you're required to do is really a bivariate analysis on your data. So you don't have to bring in a whole bunch of stuff. And we're going to see that sometimes that doesn't make sense. Okay. We just want to make sure that we can consider relationships or patterns. And again, the answer to the question of the belt exam, we're going to ask you a question. There's going to be a reason why you've been hired. Use that question to analyze your data. Don't just throw in a graph that makes no sense for anything, right? If I'm wanting to say, like, help me understand why, help me understand literacy rates. And I just throw in like, here's a bar graph of age. So, well, that doesn't do, maybe, doesn't really necessarily do much. So make sure we are dealing with that. So when we're dealing with multivariate and or bivariate visualizations or just bivariate data, and we're wanting to compare, there's this thing called correlation. And what it does is it tells us if how two variables tend to change together, or if there is some sort of change together. So when one goes up, the other goes up, right? So if an example would be for me, right? Like a weird correlation would be the more pizza I eat, the more weight I gain, right? Like that is a positive, that's what we call a positive correlation. The other would be a negative correlation, meaning when one goes up, the other tends to go down. A great example right now is gasoline, right? While supply is low, our demand, while supply is low, like our price would go way up, right? So that's a negative correlation with that. But so with correlation, we have this thing called the coefficient, or R. So that's basically our number that allows us to quantify the extent to which two variables are correlated by using the correlation coefficient of R. So if we want to see if two columns are correlated, we would calculate this number, and it'll give us either a positive or a negative number, right? It has this range for R where one is there's a strong positive correlation. If I eat pizza, I will gain weight, right? That is like 1. Also, there on the other side for a negative correlation would be a -1, right? And so very rarely, if any, you will see like a positive one. We're going to look at a heat map here in a bit, but it's somewhere in between here. The closer to 0 we get means that there is no correlation, right? Positive or negative, no correlation on either side. If it's negative 0.00000001, that's a very, very weak to no correlation, right? Same thing on 0.0001. And so by finding out this coefficient, we can see how correlated values are. Well, the nice thing is that Pandas actually allows us just to do that, where I can say correlation equals, I pass in the first column, and I want to see how correlated it is to, and then I pass in my second column. So if I wanted to see the correlation of calories per serving, if we're dealing with cereal, right? I just have to say calories per cereal dot core, and then I pass in which column I want to see the correlation, and then it will spit out and calculate this number for me. So I don't have to do any weird calculation. It will do that for me. Just as a general rule of thumb, you don't, and this is on the positive and the negative side as well. So -0.3 to -0.5, right? Sort of switches on both. Anywhere from 0.3 to 0.5 we'd consider a low correlation. So like, there's like a low correlation there. It's not super strong. 0.5 to 0.7 is moderate. And then a strong correlation is anything above 0.7. Now, again, these are not necessarily, there's not like an industry standard for what these are, but these are pretty generally like a general accepted sort of range and value for correlation. One thing to note though, is correlation does not always equal causation. Here we've got a graph, right? Which is sort of hard to understand. There's a bunch of stuff going on, but basically what this does is it is graphing the swimming pool drownings from 1999 to 2009 and the number of films Nicolas Cage starred in, right? And if we sort of just look at this and eyeball it, they look pretty similar. There's actually a correlation of 0.66, which we say is a moderate correlation. Like it's almost to a strong correlation. Although they're correlated, I would hope to God, right, that the more Nicolas Cage movies he appears in, there's not for some reason making more people drown, right? So what we would say is, yes, there is a strong correlation, but there is no causation. So just because there is a strong correlation, we would want to go and investigate those and say, what's happening here? What's going on, right? Again, just from knowing our data, knowing that Nicolas Cage films and drownings have nothing to do, hopefully, with one another, right? And so just always be prepared that correlation does not always equal causation. Cool. So what I can do, if I just wanted to look at a data frame and say, I just want to see like, what are the correlations of my data set? I can just say data set. We say DF, or in this case, the data set's called serial.core. And that will actually get me this big sort of graph that goes, and it will have calories per serving. And so it has every single column this way, and then every single column this way. And you can see that if I wanted to see the correlation between calories per serving and grams of fat, it is 0.4986610. Just know that you're always going to have these ones going across. And that's because I'm comparing calories per serving with calories per serving. And anytime we are trying to see the correlation of a column on itself, we're always going to get a 1, right? So don't just be like, oh, it's a super strong correlation. Well, yeah, obviously, like as milligrams of sodium goes up, milligrams of sodium goes up or down, right? So just know that if you see that 1, that is just accounting for, I'm now comparing calories per serving to calories per serving, which will always have a perfect correlation there. Cool. Now, if I wanted to visually see this, there's a great thing I can do with Seaborn, and it does a whole bunch of stuff for me to where I can import Seaborn as SNS. I create my correlation and I keep it in this variable of core. Something we didn't talk about is this plt.figure. That is handling this entire, we talked about it in the office hour and I recorded it. So if you don't know what that is, there's an explanation. I won't say great because I said it, but there's an explanation of what figure is. But this is just us declaring the fig size, basically how big we want this to be. Oops, sorry about that. And then all I have to do is I say heat map. I pass in the value that I want to heat map. And then there are some other things that I can do. In this case, I wanted it to be some nice blues, right? To where it goes from white to dark blue. So I pass in a C map of blue. There's a ton of different colors. There's a ton of different things you can do there. So we just said blues because I think it looks really nice. And then secondly, we said anot true, meaning do I want the numbers or not? If I didn't, it's not going to show that. It's not going to show these actual, like your actual R, your coefficient. So by saying anot true, it will show you the actual correlation values. But I can see here that milligrams of potassium and grams of dietary fiber are very strongly correlated, right? It's 0.9. And then rating of cereal and grams of sugar is negatively correlated pretty strongly, which is interesting. You would think more sugar, more people like it. So any questions on sort of these correlations? Okay. This is again, this is called a heat map. I guess in theory, it's multivariate because you're doing multiple columns. On your exam, if you did this, would I count it? Probably, but challenge yourself. Okay. Another one that is really popular and a great one to know is just a scatter plot, right? And so just from a basic perspective of a scatter plot has an X and a Y axis, and then we can take that, either that correlation, or we can take whatever we're wanting to do and see and plot the actual values on my X and my Y axis. So when I'm dealing with scatter plots, if I'm comparing two columns, right? If I see this trend going up, that tells me that I've got a positive correlation, right? As X increases, Y also increases. Vice versa, if I am dealing with if I have a negative correlation, it's basically seeing as X increases, Y decreases. That's again our negative correlation. But if I do a scatter plot and I'm trying to figure out the correlation here, and it's just scattered, right? It lives up to its name of a scatter plot. It's just very scattered. That would tell me just visually, I can look and say, there's probably not very much of a correlation there. Scatter plots are really easy to do. So here, this is just a scatter plot in Python where I can say scatter.plot.scatter. So this is in the same way where we did dot plot and we typed in the kind of bar. If I want to do a scatter, I have to say dot scatter, and then I actually have to pass it my X and my Y axis because I am calling it on the data frame. I can just pass the columns there and I don't have to say DF or anything like that. But I can see sort of, right, if I'm looking at this, that this is a positive correlation to where I see, okay, as X increases, Y also increases, right? That tells me that there's a positive correlation. We're going to actually build these out in a bit. And there's a great one that will give you even more like a reg plot in a linear model. But what I would do is on the exam, you create the scatter plot, and there's two things you got to do. And if you look at this template, it also says you must interpret each visualization. And so as you create this, you would say, on average, cereals with more sugar also have more calories, and cereals with more calories also have more sugar, right? So I'm just interpreting what I'm seeing. There is a positive correlation. It seems as if as the grams of sugar increases, so does the calories per serving. That would be a great analyzation or interpretation of your visualization. We can use group by to make bar charts, right? So if I wanted to compare the manufacturer and how many, what is like the average calories per serving per manufacturer, group by is a great tool for that. So if I want to say like manufacturer calories, I said cereal.group by, I want to group by the manufacturer. Then I want to look at the calories per serving dot mean. So it's just what is the average calories. And if I'm looking at it, then I can plot this to where I am getting the average calories and the actual manufacturer right here, right? So group by is a great one if you're dealing with bar charts. Just as a reminder, bar charts are reserved for what type of column? Anybody remember?
Categorical.
Categorical. Yes, thank you, David. Do not do a numerical value. Do not do a bar chart on that. I'll lose my mind. I mean, it has that, but of your X, don't let that be that unless you're doing a bar H. Cool. So if I wanted a vertical bar chart, what I can also do is just, plt.bar, where I say the index, I'm going to pass in the index that we just had, that we just created, this group by, right? Because remember how we do index with our series, and we take this guy right here, and then here's the values. So I can just say my X is my index and my Y is my values. So I would say, here's my different groups, and then how much they can go up. And I can handle labels by doing the Y label, X label. I can rotate this by doing X ticks. This is just in matplotlib. And if I wanted to see it, another tool you can say is just plt.show, and it'll make sure it shows it no matter what. Here's how you would do, I'm not going to go through this. Here's how you do a horizontal bar chart. I want to make sure we actually code some too, but you have access to this as well. And then if we wanted to sort it, we could always just sort the values and do from, largest to smallest there. Okay. Now, Seaborn is really going to be your best friend in this. Seaborn out of the box does a ton of stuff and allows for trivariate analysis. The way it does that is in the same way I just call a bar plot where I have my data because I'm dealing with Seaborn. I have to pass in which data I'm working with. I create my X and my Y, but I can also give a hue. And if this is great, if I've just got a few things, like in this case, it's hot and cold. What if I do hue of type now, not only is it going to do the different types or the different manufacturers and the calories per serving, but it's also going to give me this hot and this cold because there's two types, right? It was hot or cold. You think of the Titanic as if I wanted to plot something and I wanted to have a hue of survived, it would plot like average age of women, right? And men, and then it would give a hue of if they survived and if they didn't, right? So hue is just a great little tool that allows you to add in a third variable or a third one, not necessary for the exam, but it's just a great little tool that you can do. Okay. You can also, same thing with scatter plot. If you pass in a hue, it'll now do hot and cold, which can sometimes be good, not always. Right. And we'll see in a couple, like this is just a few data points, so it looks nice, but if you have a bunch of colors all together, it can be unreadable. So we want to make sure that we want to make sure that it's serving its point. And this guy right here, this PLT legend, this B-box to anchor 1-1, that just puts this guy outside of this graph, and then it just puts it and positions it right there. So if you're wondering, how did that get out there? It's just this plt.legend. So we're saying the legend, and then we say we want to anchor it to position 1, which is up there. Any questions? I'm done with the actual slides. Any questions? Does this make sense? I know whenever we dive into the code, it'll just look different, but does this make sense? Just put a 1 in the chat if this makes sense. Tell me you're also still with me. Perfect. Okay. Okay, so for next week, we're going to talk about this stuff. We're going to cover more advanced topics. We're going to really look at what are we trying to do when we're explanatory. This is all exploratory. We're trying to find out stuff about our data. Next week, we're doing explanatory. So we're going to look at some really bad graphs. We're going to look at some different aesthetic concepts. So that's what we're going to deal with next week. So what I want to do is actually want to jump in and do this code, and I want to code along with you guys. I'm in caps lock. I'm going to put this in the chat. You all should have access to it. Let me connect it. I believe you all have access to it. Yep, anyone can get the link. So I would encourage code along. This is going to be a tool that you guys can use. Again, you can use it for your belt exam. So feel free to use that. Cool. So I've got my file that I'm dealing with here. We're dealing with cleaned medical data, right? I've got my file here, and let's just go ahead and see it visually. df.head. Cool. So we're looking, we've only got 5 rows and 32 columns. So we're crushing it. Okay. So if I wanted to make a scatter plot with LNG on the x-axis, so my longitude and my latitude. Oh, what are we doing? Oh yeah, sorry. We do have the longitude and latitude. Sorry, I got very confused. I thought I had the wrong data set. Okay, if I wanted to make a scatter plot with longitude and longitude on the x-axis and latitude on the y-axis, going back to this, can anybody remember how I would do it? I don't want to pull that sideways. Anybody remember how I would do it?
Is it PLT
Mm-hmm.
matter plot parentheses and then
We've already got dot scatter. So what I can do is now I want to create my X and my Y axis. Now there's 2 ways I can do it.
so you could do
If I,
call your data frame inside and do
yep. So I'm going to say data equals df. The reason I like doing this is because now with X, I can just refer to the column name. I can say, I think it's L and G. And for Y, I just say lat, L-A-T, right? Because I passed in this data frame as my data, I can just refer to my X and my Y as that. So now if I plot it, it's kind of fun. You see, this looks like the United States, right? It is because we plotted our longitude and latitude of the US. Cool. Now, if I didn't pass in my data frame, the other way I would have to do it is plt.scatter, where I can just pass in my df of lang and then df of lat. Right, that they do the exact same thing, but because I already explicitly said df here, I could just put lang and lat. So both of these work. Look at that. Okay, so looks fine, right? We put it there. Now, this is where I think you're really going to start seeing the power of Seaborn because it just makes it look nicer out of the gates. If I wanted to do the same thing with Seaborn, I could say SNS dot scatter plot. I'm going to pass in my data very similarly, df. My X is going to equal LNG, and then my Y is going to equal lat. And so same exact code, but because I'm using SNS and because I'm using Seaborn, now it just looks a little bit nicer, right? I've got this hue around, it doesn't look, there's a little bit more separation, which sort of tells me out of the gates that, oh, it seems like there is, really a large amount of data points within this area. Which is like Michigan area. Right? But just out of the gate, we did the same code, but Seaborn allowed us to do this. Now, this is a multivariate, right? This is us dealing with a lat and a longitude that is 2 columns. So this would be a multivariate one. Cool. Cool. So let's make a scatter plot that shows the base charge versus initial days. What it's asking us is there a relationship between base charge and initial days? So if I'm looking at my data, I'm looking and I'm saying, okay, I've got initial days and then base charge. Cool. So let's go ahead and see that. I want to use Seaborn. I guess we could use Matplotlib. Now I'm going to use Seaborn. So if I'm going to do Seaborn, again, I'm going to say SNS dot scatter plot. I'm going to pass in my data equals df. X is going to be, what do you guys think? I'm gonna say initial days.
Wait,
I'll say initial days, just because it's an independent variable we can control.
Yep, I would agree. Initial days. Y is going to equal. We're gonna call that base charge. Okay, so if I pass this in. All right, what does this tell me here? Just by looking at it.
Definitely positive correlation.
Definitely a positive correlation, right? Like this is a very, very, very positive correlation. Okay. One thing to note though, is if I have a lot of data points, this is pretty telling, like this is pretty telling, right? But if I got a lot of data points, it might fool you to where it seems like there is, but we don't really necessarily know because there's so many data points, it can kind of jumble it. With that, what we can use is something called the reg plot. And what that adds is what we call a trend line, which shows the relationship between X and Y. So what I can do is I can say SNS.regplot. Now I still pass in my data equals df. I still pass in my X, which is going to be initial days equals initial days. My Y is going to equal base charge. Perfect. Cool. Let's see what this gives me. Oh, I forgot my quotation right there. Where did I do that?
you got a double quote, looks like on base charge.
Oh, yeah. Thank you.
Mhm.
Pick one and do it. Dang it. I'm telling myself that. Okay. So now by doing this reg plot, you see that I've got this line right here. Okay. This line is, we see that it is going up, and this does sort of indicate that this is a really, really strong correlation. But if we're really looking at this, it kind of isn't beautiful, right? It's not a great looking line. And so there is, and I'm just going to hop in real fast. Here is the documentation. One thing I want to note is that if I'm looking at the documentation, here's everything I can pass in, right? My data, my Y, my X. If I go all the way down, there's 2 things I particularly care about. I don't like the way my actual dots look. I think that looks kind of gross, right? It just doesn't, I don't like, they're a little bit too big and looks a little bit jumbled. And I don't like the color of this line, right? Well, if I'm looking at this, I see that there is a scatter KWS and a line KWS for like keywords. What this allows me to do is anywhere, if I go all the way down to scatter line keywords, right? What this does is it is a keyword argument from my scatter or my plot, meaning that if you see this KWS, this line KWS, if you see those, what it's saying is it also accepts arguments from your plt.scatter and your plt.plot. So anything you can do with just .plot and .scatter, you can also pass in those arguments and it will accept it as a dictionary, right? and then apply that to this plot. If that didn't make sense, let's go ahead and walk through what I mean there. So I want to deal with this, the scatter first, right? So I'm gonna say scatter KWS. Well, I know that I can pass in a size for my scatter. And the way I do that is I say S. And then here, I'm going to say, I want the sizes 2. Now there's another way I could have done it to where I could have set it like this way, where I said, let's see it, scatter KWS equals dict, and then just said S equals 2. And this would just apply the dictionary version. I created the dictionary, but this would just make this a key value pair. Either one would have worked, but I now know that this will allow me to change the size of my scatter plots. Cool. So now that's much, much smaller. KWS is keyword arguments. It's like ArgentQuarks. Cool. Now, if I also want to change my line, I just say my line KWS. Same sort of thing. Because I have 2, I'm actually just going to say dict, because I want to make it a dictionary where I'm going to say color equals, and then I'm going to say black. I want my line to be black. Let's first see that. Cool. My line is black. And if I wanted it as a dash, you could say LS, which is for line style, equals this guy. Sorry, not dash, dotted. So now I have this dotted line, and this is much, 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 much more readable. There's a couple different things you can do where if I did this, that is dash. And if I just did 1, it's just a straight line, which is what we already had. That's what it is by default. But if I wanted it dotted, oops. And do this guy. Any questions on what I just did?
Actually, a quick question. So just
Mhm.
like in general, like the values or the sizes that we're giving in, do we know what the default is? Like what, like for example, you did S is 2, is the default like 10, or is it always 10?
Yeah, so in the documentation, it would tell you what the default is. So,
Okay.
so like if here where it says robust equals false, that's the default value, or CI is 95. So if you
Okay.
actually wanted to see what is the default, you would just go into whatever the documentation is and see by default, what is it given? And
Okay.
we're just changing that value. Great question though. Okay. Let's see. Okay, so let's actually do our try vary it real fast. We've got 10 more minutes, so I want to make sure I'm going to probably skip the LM plot. Also, I think it's a fancier version of reg plot, and I don't think it's quite necessary for right now. So let's go ahead and create this. We're going to just copy and paste this for the sake of time. But I now want to have 3. Do you guys remember what the keyword, if I wanted to add 1 more, what the keyword argument was, or the keyword was?
You.
Q, yeah. So if I wanted to see this based on complication risk, I say complication. I think it's a capital complication risk. Perfect. And now not only do I have my initial days, my base charge, I also have it spread out to where I've got a medium, high, and low complication risk, where I can say, okay, well, initially a high complication risk is going to cost you more, right? Overall, basically, we're looking that the higher the complication or risk, the more of your base charge you're going to have.
It automatically creates a legend for you?
Seaborn, just Seaborn.
Seaborn does. Okay, thanks.
Seaborn will automatically create that for you. Seaborn's awesome. Just out of the gate, it just does it for you instead of you having to build it. Cool. Again, I'm gonna skip this guy. I'll paste the code here if you guys want to dive into it. It's the same sort of thing, but if I want to deal with a reg plot with multiple hues or with a hue, then it's sort of the same thing. You can go in and sort of change it if you wanted to. I'll leave that there for you, so that way you guys have access to it, but same sort of thing. Okay, the reason is I want to get into different types than just a scatter. Cool, so let's go ahead and make a bar chart. Let's say that I want to make a bar chart to show the average initial days for those with each level of complication risk. Hint, use group by to group by the complication risk. So if I'm dealing with that, I want to create my average. So if I want to do this just normal, right, using matplotlib, then what I'm going to have to say is df.group by, I'm going to group by complication risk. Right, and then I want my initial days. Dot mean, right? Because I just want my average. Oops. Cool. And if I just hit AVG, let's see. Cool. So it gives me my average, right? It's combined them together, my high, my low, my medium, and then my average initial days. Cool. Now, then I would have to take that value and say PLT dot bar, where I'm going to pass in my avg dot index, right? Because I just want this piece, my index, and then my y is I want my initial days, which is going to be avg dot values. And I run this, and now I get this bar chart for high, low, medium. Remembering that in the same way, whenever we're doing our string calls, once I run this guy, this is my index and these are my values. So that's where I got this AVG. AVG is this whole thing. Specifically, that is the index, that is the values. That's what I'm getting at. If you're kind of like, where the heck did AVG.values and everything come from?
So technically speaking,
Okay.
When you think index, you think pretty much, let's say you go to the average. So you think a high, low, medium, they pretty much constitute index, and the values constitute like the values. So you have the x-axis and the y-axis. So x on the left, y on the right.
Yeah, yeah, exactly. So right here is a high, low, medium is my index.
Okay.
Yeah,
got it.
so it's on my X and then, yeah, perfect.
Cool.
So you see that it's kind of complicated, right? I have to do this group by in order, not complicated, but I have to do this group by, and then I have to take that and I have to plot it. With Seaborn though, and now you're going to start seeing sort of the power of Seaborn, is I can say SNS.barplot, where then I pass in data equals DF, right? As always, I want my X to be, I'm just going to copy and paste this. Guess that wasn't probably faster. And then my Y equals initial days. And as all I have to do is this. And what Seaborn will do is it will automatically group them together and then show it. So I don't have to do a group by. Seaborn just does it on its own. This is just an error, just a potential error bar. So if you're wondering what that is, that's what that is. But Seaborn will do this automatically.
What about the mean?
That's what this is. This is the mean. So if I look at medium, about 9.4. High, it's
So
just
how
right
does-
under that.
Oh, you wanted the mean.
Yeah,
The mean in group by.
this is the mean. Yeah, it did it. It automatically did it all for me. So it grouped them together and found the mean in this one line. So see these look, they're in a different order, but they're the exact same. How medium's just a little bit higher than high and then low, same sort of thing. So it already did it all for me.
So is the default to always find the mean?
Yeah, for this guy.
Okay.
Right, that's what I was asking. What if you wanted something else? How did it know that you wanted the mean?
Oh, that's just by understanding the bar plot actual method. That's what it does for me. So that's why I use that one.
So if you use bar plot, it's always the mean.
So let's see. Let's go into the documentation and see what's happening here. So it's a central tendency. Only the mean value. Yep, so it's also important to keep in mind that the bar plot shows only the mean value here. So if you wanted something different, then you would have to calculate it and use something else, right? Instead of using this bar plot. Because this will calculate the mean for me. Cool. If I wanted to change the order of these, right? If I wanted to go from like low, medium, high, I could. By doing this, we don't have any time. But I can change that just by doing order, and I just pass in a list of strings and it'll show me that. So there's tons of different things you can do. This is just a very simple bar plot. Perfect. Cool. So then let's go ahead and let's see, we've got 2 minutes left. I want to show you a heat map before we do another bar chart. I want to show you what sort of just a heat map looks like. So what I can do is I can create that correlation. So I can say core equals, and I'm just going to say, I already know preemptively that there's going to be an issue with my code. So I'm going to have to drop a column. So I'm just going to preemptively do that for the sake of time. I'm going to drop columns equals. I'm going to say red. Redness. I'll show you what it looks like if I wouldn't have dropped it. And then why I did drop it. Cool. So here I've got, let's just actually see if we can just. Cool. The reason I drop readmiss is because it has this not a number, right? And so it couldn't do this correlation. So if I did a heat map, I just see a big white line wherever this not a number is and this readmiss is. So that's why I just said df.drop, because I'm not actually dropping it. I'm just dropping it for this correlation. That core. Oh.
Might have misspelled call you.
I did. I don't know the spell. Okay, perfect. So now I've got this. I have my numeric values, right? Here are all the correlations. And if I'm just looking at this, I'm seeing if longitude and latitude have a correlation. I can start looking at this, but visually, I might want to show that in a different way. So I actually want to say SNS dot heat map. What I'm going to pass is my core, because that's now what I want to see. And then I'm going to say CMap. CMap. We saw that that was blue. So let's look at what that looks like first and then decide from there. Blues. Let's see what this looks like. What is it not like in?
Blues has to be capital.
Blues has to be capital. I had it and I second guessed myself. Okay. So here we've got this heat map, but you can see that blues is kind of confusing, right? It's just like very light blue and it's very, very small. If I want to increase the size of this, I would just say plt.figure, because that is the big piece of what I'm actually dealing with. And I'm going to say fig size equals 20, 20. And this will make this much, much bigger and much, much more readable. But we can see that it's really kind of hard to deal with with these blues, because it kind of just goes to white. So it's kind of hard to distinguish. So I want to pick another color map. I'm actually going to say cool, warm. Cool, warm. And I want to see the numerical values. So I'm going to say anot equals true, which is the annotation. So creating it. And now this gives me a much, much better understanding of sort of what's going on, right? To where red represents my, perfectly correlated. And my blues, the darker blue is closer to negative, perfectly positively correlated. Blues is closer to negatively correlated. And I can look and I say, okay, great. I've got a 0.66 over here. I've got a 0.83. I've got another 0.72. So I can look and understand the correlations. Now, this is a lot going on. And so this is just a very high level look at this heat map and handling this, but it just gives us some understanding of, what are some correlations. I can start diving into this. Now, most of them are lowly correlated, if at all correlated. So like a lot of these are very close to zero. But it seems like there's a very, like a pretty strong correlation between high blood pressure and additional charges. So if you have high blood pressure or base charge and initial days, we already saw that, or age and additional charges. So the older you are, the more likely you are to pay more. Last one I want to show you is let's go ahead and make a box plot for this. A lot of the questions were, how do we do multiple box plots? And we went through the long way today in office hour. And if you guys were in there, you're going to be very frustrated because this is a much, much easier way to do it. To where we just say sns.boxplot. So all I have to do is, again, pass in my data equals df. My x equals, let's say I wanted to see, let's take, what are my columns here? I want to do income and I want to do maybe age. Let's do X is age. That's capital. And then Y is income. Oof, age was a bad one. I want something that there's just a few values for. I think gender is on there. So let's do gender. The reason this looks so gross is because there's so many different ages, right? It's a numerical value. And so if I said something like gender, cool. Now I see there's only 3. And so it just immediately adds a box plot for all 3. If you did this and you explained why you did this or what this tells me, then that would pass. That would be just fine for the belt exam. The idea is just to explore our data and see if there's any correlations. Any of these would be perfectly fine. You don't have to do something crazy like these two. I mean, the scatter plot's pretty nice. You don't have to do anything crazy. Just plot it, something that makes sense, compare things that make sense for the question you're asked, and then explain what are you seeing from that. Any questions? Ashley asked, can we use the aims same arguments methods for matplotlib and Seaborn? It totally depends on the method if it allows you to pass it through, right? So in this guy, when we were dealing with the reg plot, this color and ls comes from the PLT, like the plt.scatter. So it comes from matplotlib because, again, remember, everything's built off of that. So as long as your method accepts those, then yeah, you can use those exact same thing. Because that's what this is. This S is 2, that comes from plt.scatter. So yes, as long as it has in the same way. Because here, right, these keyword arguments, and it says, if we scroll down to it, it comes from plt.scatter and plt.plot. Initial keyword arguments. So yeah, That's where that comes from. If we want to pass in additional keyword arguments. Any other questions? Okey doke. That's all I have for class.